Okay, result number 2. This is obviously an AP. 1 plus 2 plus 3 all the way to n is an AP. How many terms are there? N terms. So n over 2. First term plus last term. Okay? Sum to n terms of an AP. Recall? N over 2, first term plus last term. Next. This second line, this one starts with r equals to m to n. So you have first term m, second term m plus 1, third term m plus 2. How many terms are there? There should be this minus this plus 1. N, November, minus Mike plus 1. So, sum to n terms, what is it? You can write down on your own and then check with your friend. Very easy. Okay, number of terms divided by 2, first term plus last term. Come on, you can do it alone. Number of terms divided by 2, first term plus last term. Okay, next, 3. This is obviously a GP, correct? A to the power 1, A to the power 2, A to the power 3 is obviously a GP. Can you recall what is the formula for sum to n terms for a GP? Can you recall? Okay, never mind. We do a quick revision. Sn for GP, must be equals to A 1 minus r to the power of n over 1 minus r. Correct? Where n is the number of terms, n is the number of terms. Correct? R is obviously your common ratio. So in this case, quite easy. What's the first term? A 1 minus, common ratio is A, number of terms is n over 1 minus A, common ratio is A. Okay? Now if I don't have, if my first term is not A, my first term is A to the power of m, in this case, can you just correct your notes? I think there's an error here. Okay, it should be A to the power R, not just R. Okay? I sub R equals to m, oops, sorry, m, I get A to the power m, A to the power m plus 1, A to the power m plus 2, all the way to A to the power m. I think I don't need to write. You write. Can write, right? Okay, use the formula, sum to n terms, you can write. All by yourself, no problem. Alright? Formula there, quite easy, right? Back row, can you all see the small fonts? Can you all see back row? Okay, good, thank you. Okay, check answer. First term, and then what? 1 minus r to the power of n. That means n minus m plus 1 over 1 over a. 1 minus a. Okay, good. Okay. Must move faster, otherwise you all fall asleep. Too easy. Okay. What if you start with R? Just now we talked about, can I have attention? Just now in result number 2 earlier, we talked about if I sum from R equals to 1 all the way to n. If I start from R equals to 0, it doesn't make a, sorry. Say again. Oh, yes, sorry, you're right. Thank you very much. No, what are you talking? This is 1 minus A, this is 1 minus R. Common ratio is A, not AM. The denominator is 1 minus R. R is a common ratio. Is that right? Ken? Okay? Now let's carry on. If you start off from R equals to 0, it doesn't make a difference. Is that right? You will actually be the same, therefore it is the same as this. And of course, we all know what is this result. Okay? Which means whether you start from 0 or you start from 1, it doesn't make a difference. Obvious. Can you have attention? Okay, a bit of talking now. Now, if your general expression here is a C and not R, is a constant, you are actually adding C n plus 1 times, because there, how many terms are there? N minus 0 plus 1. So there are n plus 1 terms. So you add Cn plus 1 times, you actually get n plus 1 times C. Now you realize that this is not the same as starting from 1 to n C. Follow what I'm saying? Yes, it's not the same as starting from r equals to 1. Okay? Good? It's obvious. Okay, example 1.